This is question 3 from section 5.2. We want to apply the eigenvalue method to find the general solution of the given system. Use a computer system or graphing calculator to construct the direction field and typical solution curves for the given system. So in order for us to find a solution to this system using eigenvalue method, we are going to create a coefficient matrix, and these are our coefficients. Then we are going to create lambda times I, which is I is a 2 by 2 identity matrix. And then we are going to find the difference of the coefficient matrix and lambda times I. Then we are going to find the determinants for the matrix in such a way that the determinant is going to be equal to 0. So what do I mean by that? To create a coefficient matrix, we have -1, +3, 2, and -2. So the coefficient of x is -1, +3 for x1, and for x2 we have 2 and -2. This is called the coefficient matrix. Then we are supposed to subtract lambda I. I is an identity matrix that has 1 on its major diagonal, 0 elsewhere. And then once we have completed this subtraction, we want to evaluate. This is A minus lambda I. This is matrix A. This is lambda I. Then we subtract, and then we evaluate this determinant. We want to find a lambda that makes this determinant equal to 0. And that is going to create a characteristic equation and is going to give us the solution for lambda. So if you haven't had linear algebra, you just have to follow the following steps to be able to solve this system of equations. Create a coefficient matrix, multiply lambda, which is a constant, by the identity matrix, and then subtract. So when I subtract the two matrices, first I have to distribute the lambda. Lambda times 1 is lambda. Lambda times 0 is 0. Lambda times 0 is 0. Lambda times 1 is lambda. That's how you multiply a scalar by a matrix. Then you're going to subtract. When you're subtracting two matrices, you go -1 minus lambda. Then you go 2 minus 0. 3 minus 0. -2 minus lambda. So we get -1 minus lambda. 2 minus 0 is just 2. 3 minus 0 is 3. -2 minus lambda. So we call this A minus lambda I matrix. Now we are going to evaluate this determinant so that we want to find the lambda so that makes the value of this determinant equal to 0. So I have -1, negative lambda, 2, 3, -2, negative lambda. So we multiply these two. -1, negative lambda, times -2, negative lambda. That's how you evaluate a determinant. You multiply the major diagonal, this times that. You put a minus sign, then you multiply these two, 2 times 3. So you always put a minus sign. And if this 2 happen to be a negative, then negative and negative makes it positive. But the formula is multiply this diagonal minus the product of the other diagonal. So -1 times -2 is 2. -1 times negative lambda is +1 lambda. Negative lambda times -2 is +2 lambda. Negative times negative is positive lambda squared minus 6. And remember, we want this to equal to 0. So let me just organize this. I get lambda squared plus 3 lambda minus 4 is equal to 0, because 2 and -6 are like terms. lambda, one lambda and two lambdas are like terms. That's how I get that. And we call that characteristic equation. So we are going to factor -4 so that if I multiply two things, I get -4 and add the numbers, I get +3. Such numbers are +4 and -1. 4 times -1 is -4. And 4 minus 1 is +3. We set it equal to 0. So this gives us lambda is -4 and lambda is +1. Once you get your lambda, the next step is you say, okay, lambda is -4. Let me find the corresponding vector for lambda is equal to -4. So since you never had linear algebra, these are the steps that you just have to follow. So you find your lambda. You say if lambda is -4, I'm going to substitute it here. So you get -1, negative, 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 negative makes that positive. And then you have your 2, and then you have a 3. And again, you put -4 here. You have -2, negative, -4 makes that -2 plus 4, which is +2 here. If you're doing this correctly, so I have -1 plus 4, that's also +3. If you're doing this correctly, what you should get is these numbers are 3, 2. These numbers also should be a multiple of those. So if this is a 3, 2, maybe, for instance, these are exactly alike, or if it's not exactly alike, maybe you get 6 and 4. Maybe you get -6 and -4, or maybe you get -3 and -2. But you should get something that is a multiple of the first row. Okay, so that's if you have done your work correctly, that always should happen. In this case, I just got the same number on both rows, and that's perfect. But maybe I would have had this case, or maybe this would have been -6 and -4. Those are all variation, but that's what has to happen. Then the next step is you put an AB here. Let's say this AB is a vector. Let's call it V. You say the steps are, you found lambda is -4. You put -4 here and here. You come up with this matrix. These two rows must be multiple of each other. And then you multiply it by vector AB, set it equal to 0. You say, I want to find a vector, a number here, A and B, so that when I multiply it by this matrix, I do get 0. So how do we multiply matrices? You multiply this row by this column. So 3 times A, 2 times B. 3 times A plus 2 times B. If you multiply the second row, you get the same thing. So if you're doing this correctly, this is, you don't need to do it for both of them, because both equations are going to be identical. So let's say if this was a 6 and this is a 4, I multiply 6 by A, I get 6A. I multiply 4 by B, I get 4B. And they're equal to 0 because this is a 0 vector. That means you have a 0 here, 0 here. That's called a 0 vector. You can write it like that. So these two equations are the same equations, because if I divide this side by 2 and this side by 2, I get 3A plus 2B is 0. So that's why these two lines must equal to each other. So you write one of them. One of them is enough. And then you're going to solve for either A or B. Doesn't matter. Let's say I solve for A. So I'm going to subtract B from both sides. I'm trying to isolate A. I get A is -2B over 3. So you are going to that's what your job is. Your job is to look for a vector V you're looking for the vector v, so you're looking for a and b components of vector v. So you say if b is equal to, let's say, 3, you can pick any number you wish. I picked 3. You could pick -3. Why did I pick 3? Because I have a fraction and I don't want to end up with fraction because I don't like fractions. Otherwise, it's perfectly fine to have a fraction. So I put a 3 here for b. So I get -2 times 3 over 3. Remember, this is equal to my vector v. V has an a and b. I'm substituting 3 for b, so I put 3 here. 3 and 3 cancel, I get b. A is -2. Maybe another student picks -3 for b, so then you put -3 here. Negative and negative gives you +2. Maybe that's what you get. Maybe another student picks -1 for b. If I put -1 for b, -1 times -2, I get +2/3. I don't like fractions, so I won't pick fraction. I just picked that number. So anyways, that is my vector. So when lambda is -4, you get a corresponding vector for it, and that is, let's call it v of -4. V for that lambda is equal to -2 and +3. So I'm going to put this on a side. Then we are going to do the same thing for +1. So when lambda is +1, what do I get? I'm going to substitute 1 here. I get -1, -1. That gives me -2. Then I have a 2. I have a +3. I put 1 here. -2, -1 gives me -3. -1, -1 is -2 again, right? So that's -2. Do you see these two lines are multiples of each other? So let's say I'm looking for another vector AB. So that makes this equal to 0. So I multiply -2 by A and 2 by B. I set it equal to 0. I multiply 3 by A minus 3 by B, I get 0. I just want to show you these two equations are identical. If I want to simplify these equations, let's say the top equation, if I divide this by -2, I get -2 over -2 and 2 over -2. So both of them get divided by -2. -2 over -2 gives me A. 2 over -2 gives me -B is equal to 0. If I divide this equation by 3, 3 over 3 gives me A. -3 over 3 gives me -B. 0 divided by 3 is 0. So do you see? I get A minus B 0. So both equations are going to be the same once you simplify them. So these two lines are multiples of each other. So anyways, I could use either one of the equations. I'm going to solve for A. I'm going to add B to both sides. I get A is B. I want to create a vector from this AB. So remember, B, I let B equal to 1. If I put 1 here, I get A is also 1. So lambda is equal to 1. I get a vector for that 1 that gives me 1 and 1. So what do I do with these? Oops. What do I do with these? I have now my solution. My solution is going to be C1 e to the power 1 x, lambda is 1, so I put a 1 here. And then I multiply it by this corresponding vector 1, 1, plus I put a C2 e to the power -4x, because I have a lambda is -4, and the corresponding vector for it is -2 and 3. So that is called my general solution. Since it's not an initial value problem, I will not know what C1 and C2 are. The way they want you to put your answer in the computer, they want you to multiply this scalar by 1 and by 1. They want you to multiply this scalar by -2 and +3, and then they want you to add the two vectors. So if I multiply C1E1x by 1, I just get C1EX. C1E1x times 1 is C1e to the power x. I multiply C2 by both components, I get -2C2e minus 4x and 3C2e minus 4x. Lastly, I add these two. And I add these two. And that's my solution. And I believe if, let's say, somebody here had put -3 for their b and got +2, so then this would have been -3, this would have been +2, this is negative, that's positive, that would have been negative, that would have been positive, and my lab math should take all of them. So anyways, this is your solution. And then the other part where it says construct a direction field for the solution curves. The way I do this, I have told you before, you should, you have your x, there's my equation. This is my x1 prime, and this is my y x2 prime. So what they want you to do is, they want you to substitute numbers, and then when you substitute numbers, you are going to get x1 prime and x2 prime, and then you're just going to plot them. These are called your velocity vectors, and then you can pick the right answer. So let me just do one example. For instance, I have x1 prime. Let me just use a different color. So I have x1 prime is equal to minus x1 plus 2x2. So let's say I pick, you can pick 0, x is 1, y is 0, not x1. x1 is 1 and x2 is 0. So if I put 1 here, I get -1. If I put 0 here, I get 0. -1 plus 0 is -1. Then my other equation is x2 prime is equal to 3x1 minus 2x2. I cut my mistake. If I put 1 for x1, I had a negative here, so I get -1. So this is -1. Oh, okay. Then I'm going to put that 1 and 0 here to find the second component. So I put 1 for x and 0 for 1 for x1 and 0 for x2. 3 times x1, 3 times 1 is 3, 2 times 0 is 0. So I just get a +3. So then what do I do? This is my x1, this is my x2. I go to this point where x is 1, y is 0, and then I have this vector. This vector is -1, that means go this way, and then up 3 units. So then I get that vector. And then you just compare what you get with the pictures to find out which one is the correct answer. Let me just do one more. Let's say this time I am going to pick this point here. That point is x is 0, y is 1. So I'm going to put 0 for x. I'm sorry, I keep calling it x and y. I have x1 and x2. So I pick 0 for x1, 1 for x2. So then what do I get? 0 plus 2. And I do the same thing here. I put 0 and 1 here. So this is your x prime 1 and this is your x prime 2. So when I pick 0 for x1 and 1 for that, I get -2. So that means when I go here, it says x, this is 2, and this is positive 2. Oops, no, positive 2 is not that way. Why do I do that? Positive 2 is this way, and then I have a negative 2. Negative 2 is 1 and 2. So I have to go down this way. But right now they're clashing, but you should just make the scale. You just want to know the direction pretty much. So this is going to give you a direction this way, like that. And this one is going to be that way. Let's do one more. Let's say I go to this point here, where x is -1, x1 is -1, and x2 is +1. So I put -1 here and +1 here. Negative, negative makes that positive. 1 times 2 is 2. So I get 0.3, comma. I put -1 for x1, +1 for x2. So I get -3 minus 2 gives me -5. So if I go to this point, I get +3, 1, 2, 3, and -5, 1, 2, 3, 5. You get a vector like that. So that's how you get an idea about the directions of the vectors, and then you can pick the right answer. So I stop here.